ओके,
स्क्रीन दिसत नाही सर.
दिसत नाहीये. हा ते विचारतोय. तुम्हाला पॉलिमर्स असं दिसत नाही का स्क्रीनवर?
नाही सर.
ओके, प्रॉब्लेम आहे. आता बघा, दिसतंय?
हा सर. येस सर.
Okay, thank you. Okay, so last time under prerequisite we were discussing basically organic compounds because we have one module named polymers, especially high polymers or engineering polymers, right? So let me see. Okay, the recording is on. So under polymers, we have studied a definition with respect to very basic polymer molecule, that is polyethylene. You must have heard about this polyethylene bags and all polyethylene bottles. So with respect to that, we have studied series of polymers. Okay. So this is what we have defined polymers. The polymers or engineering polymers are high molecular weight compounds, okay, and they are produced by repeated linking of low molecular weight compounds called as monomers, right? So in engineering, we call this polymer as a basic engineering material. So we have three types of engineering materials. Okay, first is metals and metallic compound. These are major engineering materials, right? So say maybe iron or steel or copper or brass or bronze, right? The first category of engineering materials. Then second category is ceramics, right? You might have heard about it. Like for example, say alumina, right? Silicon carbide. These are the ceramics. And third category is these polymers. So there is a one more category, composite, which is actually mixture of these three or maybe two. Okay, as per required application. So metals and metallic compounds, then ceramics and polymers. These are three basic engineering materials. Okay, and composite is combination of these three. So the polymer category is actually uh, having low density. So what is advantage of polymers upon the remaining engineering materials? So metals, they have very high density. Density you must have studied, mass upon volume. Okay. So mass upon volume, that is density of metals and alloys, very huge. Okay. So sometimes for some particular application, like say aerospace application, we don't want huge weight. Okay. So polymers will help us in that case because polymers, they have low density, or we can say lowest density in engineering material. They are polymers. Mass per unit volume is less. That is beauty of this material. And we define these polymers as high molecular weight compounds because we have studied lot of organic and inorganic compounds. So polymers are not ordinary compound. If you look at this molecule, polyethylene, so this is a huge molecule. So ethylene linkages, or we can say this ethylene linkage is linked to several other ethylene linkages, or we can say n such ethylene linkages, they are combined together. What we have is a polymer. So we can say ethylene or polymer is a huge molecule, right? And it is different from other ordinary molecules. For example, ethylene. Ethylene is not polymer. Okay, it's a simple CH2 CH2. I mean simple organic molecule. But when we link such ethylene molecules together, we have polymer. So polymer is basically high molecular compound and formed by repeated linking of low molecular weight compound that we have studied last time. And by knowing this reaction, we are able to write several polymer structures that we have studied last time. Okay. So let us continuing with this, there is problem with my keyboard. Today, basically, we will see other category of polymers. We last time we have studied this category. This category is what? Ethylene and derivatives of ethylene, okay, and their corresponding polymers. Say, for example, ethylene to polyethylene, then ethylene to polyethylene that we have studied. Okay, so what we have studied last time is this one category of polymers, engineering polymers. So, sorry. So if you're able to draw this molecule, so say CH2 double bond CH2, this is a simple monomer ethylene, right? So when we heat it under certain condition of pressure, temperature, and maybe catalyst, okay, we must take n such molecules. So one molecule cannot be polymerized. So what will happen with the help of this pi bond, one pi bond, n molecules will link together. So there is no change in number of carbon and hydrogen. CH2 will remain as it is. Only this double bond is converted to single bond. So in fact, this double bond is utilized for linking of n such molecules. So that is what this is, polyethylene. Okay, polyethylene, and it is prepared from ethylene molecule. Okay, so that we have studied last time, and then we studied few other polymers, okay, having similar structure. Similar structure means what? Similar category, addition polymer, okay, utilizing this pi bond and polymerase chain. So first we will see this category, and then we will go for the condensation polymer. This is addition polymer. Then we will see another category of engineering polymers, condensation polymer, and then we will see what is the exact difference between them. Then what are the properties we have, okay, with such type of polymers, and then we will see the examples and practical. Okay. So what we studied is, if I replace this hydrogen, one of the two hydrogens, by say another group, and just revising what we have studied last time. Hydrogen is replaced by say chlorine. Okay, and remaining thing is as it is, double bond CH. This is derivative of ethylene. Only hydrogen is replaced by Cl group. Okay, so if I take n such molecules and I heat them together, okay, under pressure, and maybe catalyst, then what will happen? Same kind of reaction, okay, a similar kind of reaction. Only what difference is, instead of one hydrogen, I have Cl group. Okay, otherwise this CH skeleton remains same. CH double bond CH2 as it is, and Cl attached to this. So basically, if you look at this molecule, okay, this whole molecule, right? This is what? Vinyl chloride. I already told you. What it called? Vinyl chloride. VC. Okay. So CHCl single bond CH2 is same in both the structure. If you look at this structure, CHCl CH2. What is the difference? That only double bond is removed. Double bond is not there. Okay. And what we have is polyvinyl chloride. N times this vinyl chloride are linked together. We get PVC. So we prepare pipes out of PVC that we are studying. Okay. Now, if I replace this hydrogen by say benzene ring, CH2, otherwise structure is there. It's kind of derivative ethylene, CH, right? One hydrogen is replaced by benzene ring. Okay. Otherwise, cell structure CH2 and chemical double bond. Basically, this is ethylene molecule only. Ethylene molecule only. Only one hydrogen is replaced by benzene ring. What we have is vinyl benzene. Okay. Vinyl benzene. त्याला आपण commonly काय म्हणतो styrene. पण त्याला शिकलो vinyl benzene. बघा तिन्ही मॉलिक्यूल बघितलं तर सेम आहे बघा. तिन्ही मॉलिक्यूल जवळजवळ सेमच आहे. डेरिव्हेटिव्ह ऑफ इथिलीन. फक्त तुम्हाला इथिलीन कळला. ओके. आणि रिएक्शन कळली की ती सिरीज ऑफ मॉलिक्यूल लिहू शकतो. ओके. पहिला आपण इथिलीन लिहिला, नंतर विनाइल क्लोराइड लिहिला, आता आपण काय लिहितो विनाइल बेन्झीन लिहितोय म्हणजे स्टायरीन. आता बाकीचे रिएक्शन तुम्ही डोळ्याला पण लिहू शकता. After getting under pressure in the use of catalyst, what we have is similar kind of or similar fashion. Structure is different, but fashion is same. CH linked to functional group benzene, okay, and double bond is converted to single bond. You don't forget, okay, to convert this into single bond, sigma bond, because pi bond is utilized for bonding, polymerization. CH2, no change in carbon hydrogen, okay, no loss, no addition of carbon hydrogen, whatever other elements. Only double bond is utilized. हे तुमचं ऑब्झर्वेशन महत्वाचं आहे. ओके. रिएक्शन चेंज काय झालं तिघांमध्ये हे तुम्हाला पुढे ऑब्झर्वेशन लिहायचं आहे. So n times this skeleton is repeated n times. So this is what polystyrene. Polystyrene. PS. Okay. So असे मी शेकडो मॉलिक्यूल ड्रॉ करू शकतो. All these are called as what? That I will write here. All these are called as addition. Addition polymers. Okay. Now you have to make observations out of this. तुम्हाला याच्याकडे काय काय दिसतं रिएक्शन मध्ये ह्याच्यामध्ये त्यात ते तुम्हाला लिहायचे आहेत दोघांचे डिफरन्स नंतर आता नाही. ओके. आता आपण पहिल्यांदा काय बघूया कंडेन्सेशन पॉलिमर बघूया. ठीक आहे. त्यापूर्वी तुम्हाला मी थोडक्यात सांगतो ऍडिशन पॉलिमर्स. These are all addition polymers. So what is the first property? If you observe three monomers, the first is ethylene, second is vinyl chloride, and third is styrene, means vinyl benzene. If you observe these three monomers, what will you find? You will find all are having double bond. बघा प्रत्येकामध्ये double bond आहे. Here we have double bond, here also double bond, and in third case also double bond. So this is the first property or first basic requirement to prepare addition polymer. काय म्हटलं पाहिजे? Monomers must have double bond. ओके. आता आपण हे सगळे जे आहेत त्यांना काय म्हणतो? या साईडला सगळे त्यांना मोनोमर्स म्हणतो. मोनोमर. त्याच्यावरून पॉलिमर बनवतो. आणि हे सगळे या साईडला आहेत ते पॉलिमर्स आहेत. म्हणजे ऍडिशन पॉलिमर. मी ऑलरेडी लिहिलंय. ऍडिशन पॉलिमर. ओके. सो फर्स्ट कॅटेगरी, फर्स्ट रिक्वायरमेंट इज monomers must have double bond. Basic requirement to prepare addition polymer. Okay. Additional, I would say addition engineering polymers or plastics. Okay. Then second observation maybe, you see, if you look at the reaction, there is a reactant. This is reactant. There are reaction conditions, right? There is a product, but there is no byproduct. So what is the second condition? Okay. Or second observation, no byproduct. No byproducts. Well, this is the जे आहे ते तुम्हाला लिहायचं no byproduct. Okay. Second observation. मी या रिएक्शन वरून आपण एवढं तरी ऑब्झर्वेशन देऊ शकतो. आता बाकीचे ऑब्झर्वेशन आपण हळूहळू कंडेन्सेशन पॉलिमर बघू and then we will differentiate between this. But these are the two basic observations I think everybody should realize. Okay. What is the first observation? Monomer must contain unsaturation. म्हणजे एक तरी डबल बॉन्ड पाहिजेच. At least one double. Functional group नाही आहेत बघा याच्यामध्ये. याच्यामध्ये you cannot find active functional group like OH, Cl, NH2. No active functional group is required. Not at all. Only requirement is double bond. Okay. And there is no byproduct formation. हे आपण immediate दोन observation केले. ते तुम्ही तुमच्या लक्षात ठेवा. Understand? Then we will move to the next. Okay. Now we will get to the second category of polymers, and that is condensation polymer, condensation plastics. Okay, so both are polymers only, and both are utilized in engineering, being a lower density material. Okay, so now what is basic difference between addition polymers and condensation polymers that we will see after writing chemical reaction. Now I will write one chemical reaction, I mean polymerization reaction, which we have already studied, and that is actually condensation polymer. If somebody recall this, then that is applicable. Nylon 66. I think we have studied this. Nylon 66. Okay. So this is condensation polymer. हा तुम्हाला सोपा पॉलिमर मी का घेतलाय कारण तुम्ही ऑलरेडी ते स्टडी केलं. Okay. And I know that you know the monomers for nylon 66. Okay. The first monomer is hexamethylene diamine. बघा मी लिहितो तो डायरेक्ट पॉलिमर तुम्हाला माहिती आहे hexamethylene. So hexamethylene. So this is methylene, and hexa means 6 times. Okay, 6 times methylene. Hexamethylene diamine. So one amine this side and another amine on the other side. Okay, so I should write what? Hexamethylene. Okay, diamine. Hexamethylene diamine. This is my one monomer. Okay. Then second monomer is actually adipic acid. I will write name first. So the adipic acid, if you look at the name adipic acid, you cannot judge the structure. Okay. But if I say tetramethylene dicarboxylic acid is adipic acid, then you are able to write. Okay, you are able to understand. Tetramethylene. So I should write methylene. Okay, this is methylene group. Tetra means 4 times, right? And what I said, tetramethylene dicarboxylic acid. Okay, carboxylic acid don't function like that. COOH from this side and another side COOH. Okay, so these are our two monomers, low molecular weight compound, and they will combine together and they will produce polymer, and that is condensation polymer. So why condensation polymer? Because there is condensation reaction. Now question is, what is condensation reaction? So reaction where the functional group, active functional groups react together and simple molecules are removed. That is what condensation. You understand? So it's a reaction between two organic compounds, okay, with their functional groups. Actually, functional groups are reacting together when we heat them, and there is a removal of simple molecules. This okay. So in this case, can somebody guess the possible byproduct? Possible byproduct means simple molecule that can be removed. Yeah, I know. You can judge it. A water molecule can be removed. You can see OH over here and one hydrogen over here. So that will be the water molecule removed from, okay, the reaction. So when I heat them together, right, okay, under maybe pressure, that is specially if required, then what will happen? So there is a removal of H2O molecule. So I should write H minus H2O. So what will happen? I should write. So here, see, at the terminal group, the terminal NH2 group, there is also loss of a water molecule. So I should write NH because this hydrogen is also lost as a water molecule by combining with another adipic acid molecule from the other side, right? So NH, with this will be converted to NH. So then I should write CH2 6. There is no reaction with methylene group. Hexamethylene will remain as it is. Then I should write NH because this hydrogen is lost in water molecule. So I should write NH. Okay. Then this NH will link to now adipic acid. Where it will link? That I should show you. So now this OH group is lost as a water molecule. So obviously this NH will link to carbonyl carbon, means this CO group. Okay, CO highlighted. So NH will link to CO. So I should write CO. So CO can be written as C double bond O, this carbonyl. Okay, so NH will link to this CO. Then CO link to CH2 4. There is no change in methylene group. CH2 4 as it is. Okay. Then this CH2, this 4 methylene group will link to again CO, because this OH lost as a water molecule by reacting with NH group of another hexamethylene diamine from this side. Okay, so this OH is also lost as a water molecule. So only CO will remain at the end. So I should write CO means C double bond O actually. Okay, and this is continued from both this side. Okay, and I should write N molecules because polymer is a huge chain. Okay, so I should take N molecules of N molecules of hexamethylene diamine and N molecules of adipic acid. I will get this molecule nylon 66. Okay, so it has this structure NH. Okay, NH from this amino group, then linked to single bond, then this is linked to CH6 again to NH. Now this NH linked to carbonyl group, okay, of adipic acid. Carbonyl group linked to 2 methylene group and 4 methylene group and 4 methylene group linked to. It's a very simple reaction which we have already studied in 12th standard. Only removal of water molecule, that's all. Okay. So this is what condensation polymerization, and polymer produced is condensation. Now, if you observe this reaction, you can write those observations as a differentiating point with respect to addition polymer. Okay, then मगाशी आपण जे polyethylene बघितली, polyethylene, polyvinyl chloride, okay, then polystyrene, these are addition polymers. Now this is nylon 66 is a condensation polymer. So what is the exact difference between these two categories of polymers? तर मगाशी आपण पाहिलं तर काय होतं in case of addition polymerization, what is basic requirement? Double bond पाहिजे addition polymer. Okay, इथे काय पाहिजे बघा, if you look at the monomer, there is no double bond. If you look at this monomer, what is this? Hexamethylene diamine or another monomer, adipic acid, there is no double bond. So double bond is not required. Addition polymer double bond पाहिजे, पण condensation polymer double bond ची गरज नाही. So what is required? Active functional group, because condensation is what reacts with functional group after heating. That is what condensation with the removal of simple molecules. So to prepare condensation polymers, we must have monomers having active functional group like carboxylic acid. In this case, there is carboxylic acid. I mean, we have 2 carboxylic acid groups. So this is the monomer for condensation polymerization. And in this hexamethylene diamine case, we have NH2 being active functional group. We have 2 NH2 groups. Okay, at both the ends. So NH2 is amine and carboxylic acid. These are the active functional groups present in the monomers for the preparation of nylon 66. So we can say the basic requirement to prepare nylon 66 means condensation polymer is what? Presence of active functional groups. It's a must. Okay, आपल्याला आतमध्ये double bond ची गरज नाही. Okay, this is first observation. You can, or immediate observation you can make. Now, second observation, in case of identical polymers, what second observation we make? There is no removal of simple molecule. Okay, only double bond was utilized in case of polyethylene. Okay, double bond offerla. No loss of carbon, hydrogen, nothing was lost. Okay, so in case of additional polymerization or additional polymers, we can say there is no loss of simple molecule. But in case of condensation polymers, there is always loss of simple molecules like H2O, CO2, HCl, etc., etc. Okay, so we can have this as a second observation. There is a removal of simple molecule in case of condensation. झाले तुमचे 2-3 पॉइंट झाले बघा. ओके, असे तुम्ही डिफरन्शिएशन फॉर्म्युला तयार करायला. नाउ इन आवर सिलेबस वी हॅव conditional polymer as well as addition polymer. Okay, so before going to those, we will see the actual differentiation, how they are differentiated, that we will see. Okay, so this is what the, these are what differentiation points. Okay. So what I wrote is addition or chain polymerization. So you can say addition polymers are also called as a chain polymer. Okay. And condensation, they are also called as a step polymer or step polymerization. Method is polymerization. Okay. तर आपण एक एक्झाम्पल काय काय बघितली, ऍडिशन पॉलिमर एक्झाम्पल काय बघितलं आपण, तर ऍडिशन पॉलिमरला आपण एक्झाम्पल काय बघितलं, पॉलिइथिलीन. पॉलिइथिलीन बघितलं, देन पॉलिविनाइल क्लोराइड, polystyrene, series of polymers we can draw. Okay, and in case of condensation polymerization, which example we have studied or taken in the last slide, nylon. Nylon 66. This is already studied. Now one example get over. Now by just looking at these polymer molecules, we can differentiate between them. Okay, we can have differentiation points. Okay. So first point would be that I already told you. Monomers must possess unsaturation. What is the meaning of unsaturation? Presence of double bond or maybe triple bond. So this is what the basic condition to prepare addition polymers. Monomers, monomers is a starting compound for preparation of polymers. There are monomer simple molecule. There are polymer. So monomers must be compulsory. Like addition polymerization. So monomers must possess unsaturation. Now, okay. Now, if you look at the example, if those I have cited, those already we have studied. One is for ethylene and propylene. Okay. So here in both the cases we have unsaturation. In case of ethylene as well as in case of propylene, we have double bond. Okay. So this is first part. Now, in case of condensation polymer, or step polymerization, what would be the first step or first differentiation point with respect to monomers? Okay, so that is what, not unsaturation but active functional group. Monomers must possess active functional groups. This monomers बद्दल बोलूया आपण कॉमन केली. First point for condensation polymerization must possess active functional group. What is active functional group? Functional group like OH with hydroxy, carboxy, halogen, amines, etc. etc. We have a lot of functional groups. So monomer must possess this functional group, because condensation itself is a reaction between functional group after heating. Okay, with the removal of simple molecules like H2. So functional group is basic requirement and not a double bond. Okay. So first comment in both the cases is on monomer. Now second comment would be no removal of simple molecules. No removal of simple molecules during polymerization. The polyethylene is produced from ethylene. Ethylene is converted to polyethylene. So no removal of carbon and hydrogen. Even single atom is also not removed. Only double bond is shifted. So that is what the important property of addition polymers or addition polymerization is, no removal of simple molecules. And in this case, there is removal. We have seen in case of nylon 66 also. In case of nylon 66, okay, what we observe, there is removal of water, several water molecules, right? Okay, by reaction of NH2 and COH functional group. NH2 of hexamethyl diamine and COH of tetramethyl dicarboxylic acid. Adipic acid. Okay, adipic acid is a COH group and hexamethyl diamine is a NH2 group. Hexamethyl reaction with condensation reaction and molecule is lost. So we can say in case of undifferential polymerization, there is removal of simple molecules like H2O, HCl, etc. during polymerization. Okay, that's the second observation or second point of differentiation. Then third comment, okay, with respect to again reaction which we have observed. Now, what we have observed in the reaction, there is no removal of simple molecule. दुसरा point तुम्ही बघितला तर काय होईल during polymerization there is no removal of simple molecule at all. Nothing is lost. So based on this second observation, we can write third observation. Third observation is molecular weight of polymer is exact multiple of monomers. Why exact multiple of monomers? So in case of polyethylene, ethylene is converted to polyethylene. That we have said. And there is no loss of simple molecule. So no loss of simple molecule म्हणजे काय? Exact multiple, n multiple of polyethylene is the n multiple of ethylene. जसं तुम्हाला मी अर्थ दाखवले की रिएक्शन वाटतं ते तुम्हाला लिहून दाखवतो नंतर की ही रिएक्शन आहे CH2 double bond CH2 n molecules I2 and after heating under pressure we will in place of catalyst. So what we have observed is there is just utilization of double bond. Okay, and there is no loss of simple molecules. Okay, and N. Okay, so here we have CH2, CH2. Here also we have CH2, CH2. Only changes double bond is converted to single bond. Okay, and we have a huge molecule. These N molecules cling together, and there is no byproduct. No byproduct is not there. So that is what the third point is molecular weight. If you calculate molecular weight of this, so that molecular weight of polyethylene is exact multiple म्हणजे काय n multiple of ethylene. ते ह्याचा मॉलिक्युलर तुम्हाला काढायचं असेल तर n ने ह्याला मल्टिप्लाय करायला पाहिजे कोणाला एथिलीनच्या मॉलिक्युलर वेटला मल्टिप्लाय करायला पाहिजे बिकॉज देयर इज नो लॉस नसल्यामुळे ते एक्झॅक्ट मल्टिपल आहे एक्झॅक्ट मल्टिपल ऑफ ओके so that is what the observation in case of what addition point, right? Let me erase this. So all addition polymers are like that only. They all addition polymers are exact multiple of monomers. N multiple of monomers we can say. कुठलाही घ्या पॉली विनाइल क्लोराइड आता आपण पॉलिथिन बघितलं पॉली विनाइल क्लोराइड घ्या आणि कुठलाही तुम्ही घेतला तरी you will find the same observation that polymer is exact multiple of its monomer. Now in this in another case conditional polymer or conditional polymerization, okay, there is removal of simple molecule. So here we have exactly opposite observation. Molecular weight of polymer is not exact multiple of monomers. This only not word is introduced. Why not? Because there is removal of simple molecule. So polymer produced is not exact multiple, not n multiple of monomers because there is loss of water molecule. In case of nylon synthesis, is loss of several water molecules. So nylon synthesis is not n multiple of hexamethane diamine and another IDP gas compound. So that is what the third observation, which is totally linked to the second point. Okay. What is second point? Loss of simple molecule. So because of loss of simple molecule, polymer is not exact multiple of its monomer. Then fourth point is actually the mechanism of how this polymerization is taking place. How addition polymers are being produced. So this is not a one-step reaction. We observe N-ethylene molecules. Okay, after heating, they are converted to polyethylene molecules. That we have, we have seen only one-step reaction. Actually, it is not one-step reaction. It is a very complex reaction. So first there is initiation. Okay, initiation of a chain, initiation of an ethylene molecule. There is free radical formation takes place. Then there is the propagation. And finally termination to produce polyethylene. So actually there are three steps. So mechanism, while studying mechanism, we will study this mechanism. These steps. While studying actual reaction, okay, we call it as a mechanism. We will see these steps. What is initiation, how chain initiated, and how it is propagated. get a final neutral polymer. Okay. Now, in case of condensation, how we can define condensation reaction? So it involves reaction between two functional groups. That's all. Okay, very simple. Description of condensation polymer. It involves reaction between two functional groups. But addition polymerization, there are three distinct steps. Now, fifth observation is in case of addition polymerization, catalysis must. So without catalysis, we cannot perform addition polymerization. Okay? So catalysis must, because there is initiation of a monomer. Monomer, say for example, ethylene to polyethylene. So ethylene itself cannot be, converted into polyethylene. It has to be initiated, and that initiation is being done with the help of suitable catalyst. So catalyst is must. So this is applicable to all addition polymers, all addition plastics. Okay. Then fifth point for condensation polymerization. So in this case, catalysis is not must. Okay. So what is said? May or may not be. Okay. Sometimes it is required, but always, not always. Okay. So in case of nylon 66, catalysis is not required for initiation. There is no initiation required. Because in case of condensation polymerization, we have monomers with active functional groups. So those functional groups, they have attraction between them. So without utilization of catalyst, we can have this condensation polymerization. No catalyst is required. But in case of addition polymerization, there is no active functional group, only double bonds are there. So we need to break those double bonds in case of addition. But in case of condensation polymer, there are active functional groups. They have natural attraction among themselves and they react spontaneously. And we get product, polymerized product without being used, without using catalyst. That will be fifth. Now, in case of, addition polymerization, if we want to make comment on a kinetics of reaction, the speed of reaction, so that is what the statement. Rate of polymerization is very high. In case of addition polymerization, being a chain polymerization, being a free radical reaction, this is very fast reaction as compared to condensation. So in case of condensation polymerization, it is a reaction between functional group. Okay, this is not a free radical reaction. Free radical, they are very unstable and they are not very vigorous in their reaction. But in case of condensation polymer, the reaction between functional group, it is actually slow. Okay, rate is comparative. Okay. Then if we look at the next point, so we can make comment on the final plastic produced or final polymer produced. We can make a comment on the structure of the plastic. So the structure is linear in case of addition polymers, okay, which are being prepared from unsaturated polymers. The structure remains linear. There is no cross-linking. There is hardly any branch produced. Okay. Otherwise, they are having linear. Okay. Straight chain. No branches. Okay. But in case of condensation polymers, we have cross-linked three-dimensional structure because we have a lot of functional groups involved. Okay. So the polymer chain grows three-dimensional in all three dimensions. So we get a three-dimensional network which is very strong. Okay. So in case of addition polymer, 8 differentiation point would be the strength, mechanical strength of polymer. So now addition polymers, they are what? Linear chain. So they are obviously soft, weak, and less brittle. Okay. Soft, weak, and less brittle. Why it is so? Because they have only linear chains, no cross linking. But in case of condensation polymers, if you look at their structure, as I mentioned in point number 7, they are three-dimensional. Okay, so it is considered to be very strong bonding. Okay, so we can say condensation polymers, they are very hard, strong, and more brittle. Brittle means, see, something which is hard, but easily breakable. It's a brittle. लगेच तुटतं. आपण बघितलं ग्लास त्याचे हार्ड असते पण लगेच तुटतं. That is brittle. So condensing polymers, they are more brittle, okay, but they are hard and strong. But additive polymers, they are what, soft, weak, and less brittle. So I hope you understand, you are getting the differentiating point. Okay, with respect to reaction, we have studied last time. Okay, so these are the examples of additive polymers. You see, these are we already studied: polyethylene, polystyrene. These are additive polymers: polyvinyl chloride, polypropylene. Several additive polymers we can see. Okay. So in all cases, we will observe all the eight points we have discussed. Now, in case of continuous polymerization, urea formaldehyde is the best example. Then bakelite is also called as phenol formaldehyde. Okay, nylon 66 we have studied. So these are all condensation polymers, so condensation plastic. So all these 8 points we have discussed are applicable to all these condensation. Okay, so if question is asked or somebody asks you, can you differentiate between addition and condensation polymers? So what you should do, you should not mug up this point. What you should do, you should able to write these two reactions or be able to recall reactions. Which reaction? In case of additive polymerization, which reaction we have studied? Polyethylene formation. Ethylene to polyethylene formation. He reaction to my पाहिजे. Okay? Ethylene to polyethylene reaction might paहिजे. If you know this reaction, just looking at the reaction, you can write these 8 or 9 points. 9 points will be the example. Okay. Then in case of condensing polymer, you can recall the reaction of nylon 66. If you recall this reaction, just by observing the reaction, you can write all 9 points. Yes, and you don't have to mug up. Okay. Now this molecular weight point will come later. Now we will go to the plastic which is included in the syllabus. This we study in detail afterward. Okay. So this is what the addition polymer, okay, which we are going to study in active syllabus. So if you look at the name of the polymer, actually it is plastic, very interesting plastic, polymethyl with acrylate. Acrylic म्हणतो परत वेळेला. Okay, and this is called the transparent plastic. So plastic is usually what, opaque, non-transparent, but this is what, transparent plastic. Its refractive index is very high, higher than even glass. Okay, so polymethyl with acrylic. So it's a reaction of here. So what is stated over here? It is obtained by addition polymerization. But just addition polymerization or addition polymerization. So those all 8 points are applicable to PMMA. Okay, so addition polymerization of what? Methyl with acrylate. This is the monomer. Now, just by looking at the name, you cannot imagine its structure. It's very difficult to imagine. Methyl with acrylate. No, it's not possible. Okay, this is not IUPAC. But if you know the addition, I mean the characteristics of addition polymerization, you can judge the structure of methyl with acrylate. Okay, since it is addition polymer, you must say methyl with acrylate must contain active double bond. Okay, that is what the basic observation. Okay, and in presence of hydrogen peroxide, so catalysis must, at this point also we have discussed. Okay, in case of addition polymerization, catalysis must आपला दूसरा point होता. Okay, so in this case also, just by polymerizing methyl with acrylate, which is monomer in this case, in presence of hydrogen peroxide catalyst, we can have polymethyl with acrylate. So, as I mentioned before, most of the addition polymers, they are derivative of ethylene. So this is also derivative of ethylene. Methyl with acrylate molecule. But if I just write react structure of this molecule, you will understand, yeah, it's a simple derivative of ethylene. Okay, so this is ethylene only. CH2 double bond CH2. Now both the hydrogen atoms, they are replaced by something. What is that something that I will tell you? So one is methyl, as mentioned over here, methyl. Another is meth acrylate, So this is 8 means ester, you have studied. So with acrylate group is added. So this is with acrylate. Okay. So actually this is ethylene molecule only. Uh, both the hydrogens of one of the CH2 group are replaced by another functional group. One is methyl and another is meth acrylate functional group. This is what our monomer starting point of our reaction. Okay. So N molecules, as I told you, one molecule cannot be polymerized. So we must take N molecules. We must take N molecules. Okay. So these N molecules will polymerize, heat. So this is what the first condition. Second, catalysis must. Now if you look at the monomer molecule, you will find double bond. This is property of additive polymerization. So double bond is there, catalysis must. Now what will happen? What will happen to the structure of so if you can somebody judge the structure? Yeah, we can easily judge the structure because we already studied a lot of additive polymer. So what is happening during additive polymerization? Only double bond. This double bond will be utilized. Only double bond is utilized. There is no reaction between functional group. Even though there is one functional group, COCH3, there is no reaction at all. Okay. Only double bond will be utilized for the linking of N this methyl meth acrylate molecule. Methyl meth acrylate. So double bond will be utilized. So in the PMMA structure is very simple or similar. Only there is no double bond. That is the difference. So that is what I wrote for CH2 part. Then double bond is utilized. So there is no more double bond. This carbon, same. If you look at the structure of methyl meth acrylate monomer, this part is same. Okay. Then another part, COCH3 and CH3. This is also same. So skeleton remains same. If you observe this molecule and monomer molecule, skeleton is same. You will find CH2, C, CO, CH3, CH3. Here also CH2, C, CO, CH3, CH3. So there is no loss of simple atom or simple molecule. That is the property of the additive polymer. Okay, the skeleton will remain as it is. Only double bond is removed. Removed is what actually that is utilized for linking of N such molecules. So what we have is this. Okay, building of a PMMA. N molecules are linked together. Okay, so this is what methyl meth acrylate, and this is PMMA. Okay, so now if you apply all 8 points to this, you will definitely realize what is additive. Okay. So first point we have discussed is presence of unsaturation, that is there. Okay. Then second point is there is no loss of simple molecule. There is no simple molecule loss. So molecular weight of polymer PMMA is n multiple of monomer. That is also applicable. Catalyst is must applicable. Then structure, this is linear polymer. There is no cross linking, right? Now since this is linear polymer, this is soft. We have an observation. This is soft. Okay, soft and less brittle. Okay, soft and less brittle. We have an observation. Structure only. And then what is the specialty of this polymer? The specialty is what? Refractive index. The refractive index of this polymer is higher than even glass. म्हणजे हा glass पेक्षा कसा आहे जास्त transparent आहे. The polymer, the plastic, more transparent than glass. पुन्हा mostly optics मध्ये वापरला जातो. Even PMMA पासून आपण आपले eyes, artificial eye जो असतो तो PMMA पासून बनवला जातो. And it's a very high refractive index. Okay, so all the 8 points we have already discussed, they are applicable to this. So these are what the properties. The softening plastic, thermo softening plastic. And what is thermo softening plastic? That we will see later. Actually, we soften after heating, reversible to the heat, and has high softening temperature. Softening temperature compared to the good 130. This is actually required property while molding, giving shape to the plastic. The temperature, softening temperature जर तिथे खूप कमी असेल तर खूप जास्त असेल, so it creates difficulty in fabrication. So good softening temperature. Okay. It has low scratch resistance. Okay. ते सॉफ्ट जरी असला तरी स्क्रॅच रेजिस्टन्स जास्त आहे. हार्डनेस जरी कमी असला, सॉफ्ट असला तरी स्क्रॅच. It has high refractive index तुम्हाला सांगितलं 1.59 and hence has high optical transparency, more transparent than glass. तुम्ही इमॅजिन करा, ग्लासला आणि TMML जर तुम्ही बाजूला ठेवला तर तुम्हाला आश्चर्य वाटेल. ओके, ग्लास पेक्षाही ते ट्रान्सपरंट. It has high resistance to sunlight and high ability of transmitting light, and accordingly uses we बघायचं सगळे तसेच आहेत. Used for making lenses, optical parts, instruments like light fixtures, artificial eye तुम्हाला बोललो मगाशी मी. Okay, for making window glasses. They are also used the paint, acrylic paint आपण म्हणतो बघा, आपण वापरतो acrylic paint आहे म्हणतो. So that acrylic paint we add the paint. So this is what the important industrial important plastic or polymer, and it is additive polymer. Okay, so next time we will see few more examples. We will see the example for condensation polymer also. Okay, if you have any question in your mind, okay, you can message me, you can WhatsApp me, or you may call me. Also, if you have any query about any other subject, okay, you can contact to this respective teacher or to your Mane madam or me. You can come personally to the college. You can resolve your queries. Okay, you can take appointment and come anytime. And this about recording, I already mentioned. We have all recording with us. We will get all recording time. So we stop for today. We'll see next time. Now maths lecture will be starting. So bye for now. Have a good day.